greetings to my colleagues who are editing this later. This is Ian from the Fishy Filaments, and we'll be talking about how we came and everything. So, greetings to Cornwall, first of all.
Hi.
Hi. All right. So, how did you came with the idea of fishy filaments? Because is this really not classical ones, but also a trending thing to make sustainable products and thinking much more ecological.
Yeah, so my background is in raw materials, mining, mineral processing, large energy projects, that kind of thing. So I'm coming from an engineering background, but always with very much an eye to the sustainable supply chains. And I was working on some technologies for sustainable metals production, metal powders for 3D printing. For a large mining client, and it came to me that actually these technologies that I was developing could be applied into plastics recycling as well. And where I live in the tip of Cornwall in the southwest of the UK, there are only really two sources of plastics to recycle. One is domestic waste, so effectively just your bin, your trash cans, and the recycled bottles, water bottles, that kind of thing, or fisheries waste, so old fishing nets. And those are effectively the only two sources of plastics to recycle down here. And I turned my attention to fisheries because it was a higher grade of plastics. It had a more urgent requirement for innovation. And I could see a way of applying the technologies I was developing into that challenge. So the source material was perfect for the challenge. There was a definite need there for a more sustainable solution to be developed for that particular sector. And the material was of a really high quality, so it opened the door for uses like 3D printing. Without that kind of the high value end use, it would be tricky to develop a new hardware solution, which is effectively what we're doing here at Fishy Filaments. So we're a hardware developer rather than a materials developer by motivation. The materials development is part of the story rather than the whole story.
Lovely. And what was your goal? Like to set up so to prepare some materials for this technical usage, or what was the idea in the background?
Uh, it, it, there are different ways of approaching sustainability. My particular area is what's known as resource efficiency. So making sure that valuable materials don't get thrown away and effectively used in a single-use mode. So things that have a potential second use are recovered and used in a valuable way for a second, third, fourth, fifth, sixth, adding value each time they go around that loop, rather than just single use in industry or commerce and then either burnt or buried or otherwise thrown away. Unfortunately, in the marine environment, if you throw away fishing nets into the sea, they tend to last for a very, very long time. And they create harm out there as well. So apart from the kind of immediate impacts in terms of litter and problems with emissions and it just being a bit of a hazard in the marine environment, there's a phenomenon called ghost fishing where the nets continue to catch fish throughout their life, even if they're not being used anymore. And it's because the nets can be around for many hundreds of years. That the material is that tough; they'll be around for hundreds of years and create a hazard in the marine environment for a very long time. So the potential for harm from this particular industrial waste is high, and the potential for good is high. So it's a useful material that should be recovered both from a prevention of harm point of view and from an economic benefit point of view.
You mentioned this ghost fishing. It is something you observed before and saw as an issue, or you find it out later while thinking about this idea of recycling fishing nets?
It's something that our business wasn't designed to address directly. The Fishy Filaments model is to collect nets direct from the fishermen at the end of their useful life, so prevent loss into the wide environment rather than clean up afterwards. So I know there are groups and companies out there retrieving lost nets. Our goal is to stop those nets getting out there in the first place. So we're very much in what we call prevention mode rather than a cure mode. But it's a benefit rather than being the primary goal. It's a byproduct of doing the right thing with that materials and having that closed system straight from the fisherman straight into the second generation and third generation of use.
This is absolutely fantastic. I also think that prevention is much more important than saving later, because you actually can save also the time and all the resources. So you, this was my next question: is it, how did you get to the raw materials? So you have like a chain of your suppliers, or how did you get these nets?
So because it's an immediate challenge for the fishermen, they have a cost imposed on them for disposal. So they're looking for ways to dispose of their nets without having to pay for it. So they give me their nets
Oh,
for free. So that just by giving them their nets to me for free, they avoid that disposal cost. So it works great on both sides. I get a free resource that I can then work with and regenerate and give us a valuable second, third life. And the fishermen avoid an economic cost, and also give themselves the kind of a sustainable outlet for their waste materials. So it closes their waste management responsibilities as well.
awesome. And are they interested, by the way? Like, how are you working and what are you doing with these nets?
Yes, absolutely. So I have quite a close relationship with some of the skippers down here in the Newlyn Harbour. The harbour itself is supporting our business by providing space and access, and we provide some spare parts for their operations. So we'll get into OrCA in a moment, but it's kind of applicable right now. The the harbour has a fish sales function, so that the fish that the fishermen land have to be sold on a market, and that market has lots and lots of boxes full of fish and ice, and these boxes of fish are transported through the market as they're bought and sold every morning, 5 in the morning before it gets light. And that at the end of each sales session, they have to rewash the boxes that are used in this market to transport fish around, and they have a very big industrial dishwasher in effect,
Okay.
very hot, very aggressive soap in it, and some of the parts inside it get dissolved away by the aggressive washing detergents, and their washer is about 25 years old, so they can't get spare parts. So recently we provided some spare parts for them. Very simple geometries, not terribly challenging to print, but we're finding that it's super hardy, and we can provide spare parts on demand for them. So keep their critical operations going, and they don't need to worry about spare parts for their machine anymore. So they're interested in both the point of view is that the point of view of waste disposal for their end of life nets, but also in how we might use that material in their own businesses as well. So it's treating both sides of the interest, I think.
That's amazing. That's really awesome that you are helping each other. And I also spoke like 2 days ago with Mike, and he was also telling me that you're actually like creating like a local help system, or how to call it. Like you are helping each other, because Cornwall is such a wonderful place when everybody helps each other, and I love this idea.
Yeah, I mean, it's a fantastic place for collaboration and cooperation. We're almost like an island compared with the rest of the UK. We're right down in the tip, right down in the corner of the UK. So we don't have really good transport networks, and we don't have a lot of industry down here either. So being able to support ourselves with small spare parts for critical infrastructure is quite important. But it's also a good model for how our recycling operation might work in other areas around the world, and having that localized closed loop supply chain for end-of-life fishing nets back into a locally useful material.
This is amazing. Like thinking locally is a big thing and big part of sustainable economic, I guess, because you are helping really each other and bringing all the materials and rotating it if it's possible. Like with these nylons, we are talking about at this moment at OrCA, at PA6 nylon. It's amazing. Great work.
Yeah, and it stops us having to import it from the other side of the world as well. So we all had that supply chain blip after COVID. So, and also with the Evergreen a transport ship in the Suez Canal, when everybody's supply chains kind of stopped. If we can prevent those kinds of disruptions to supply chains by having it material locally recycled and available, then that it adds resilience to our little niches of economy around the world, makes it a little bit less reliant on
This
the
one.
global supply chains.
Awesome.
Okay.
By the way, when you were gaining this fishing nets, the first idea which came to my mind was like, how do you do it that every single like this raw material is the same? Because uh, I know that soon we will release also Porthcurno. There will be this nice greenish blue in your bag, but like I know that fishing nets are like many different colors, probably different materials. How do you work with it? Like, are you some separating these parts or how?
I'm just going to step away from the camera for a moment to bring something in.
Yeah, yeah, welcome. Thank you. Wow.
Okay.
Amazing.
So this is the range of colours of nets that our local fishermen use. So all the way from very, very dark blue, almost black, and very dark green, all the way through to almost white. But most of them are kind of this light blue-green by volume, so that kind of range. But they do use different coloured nets, absolutely. You absolutely put your finger on one of our problems, which is colour control. So we have, because of the variety of colours that come into us, we split them into two product streams. One is for Porthcurno, which is a lot more consistent colour, so this kind of colour. And we don't have any of these darker colours in there, so we keep it a lot tighter in the colour spectrum for Porthcurno. For long ships, which is the base for OrCA, that will take all of the different colours. Now, all the different colours are still nylon 6. They're all identical polymers underneath. It's just a little bit of colour that's been added to them. So from a mechanical point of view, they're identical. It's just from an aesthetic point of view where they're different. So we can split those those two streams of materials, process them exactly the same way. We clean them in exactly the same way, but because of the color consistency, long ships, the more colorful, the more diverse color, that goes over to OrCA, where when we add the carbon fiber to OrCA, that color difference isn't evident. You can't see the color difference because of the carbon fiber. It covers it all. It just becomes like another black material, but another black material with some different properties to most of them. So yeah, it's if I show you what the nets look like as they actually arrive to us. So this is what they arrive looking like. They arrive with bits of other materials with them, and we have to pick all of those out and separate those out. Those aren't recyclable right now, so we have a little bit of waste. But once we've got rid of those, over 95% of that will make its way into the final product. We have very little wastage once we get rid of these non-recyclable bits. The recycling process is very efficient.
Congrats for that. And by the way, if it's not a secret, can you tell us a bit about how you are processing these nets? Like how work the process of cleaning? Because in my imagination, the fishing nets are not the cleanest thing at all, and with remains of everything.
Yeah, so the process and the hardware to achieve it is currently subject to patent application. So I'm not going to go into massive detail about
No,
it,
no,
but
no.
just to give you some of the challenges. Um, the so the biggest challenge for recycling these particular kind of nets are the knots. I'm not sure if you can
You
see
need to
that.
move it a bit. Perfect.
Yeah, so the knots are really difficult for us. There are people around the world recycling this material. They're not recycling it to a very high quality, certainly not to a quality that would be acceptable in 3D printing. And the reason is they're not addressing the construction of the nets. So our process addresses the construction of the nets, and we have some fancy little techniques that we apply within our process that gets rid of the dirt that's on each of the filaments, fishy filaments. We deal with filaments as well as produce filaments. So there is dirt, there is an algal film on each of these nets, maybe only a few cells thick, and our process gets rid of all of those algal remnants, all that contamination, right down to a cellular level. And it does it without detergent, without heat. It's a cold mechanical process, and we've done some scanning electron microscope studies to look exactly where the contamination is and how good our process is, how effective it is, and it's very, very effective. So we leave the material once it gets to this stage, which is what we produce here on site in Newlyn in Cornwall. We call a micro pellet. Once we get to that, it has virtually zero contamination in it.
So it's like a flakes.
Yeah, we call it a micro pellet. It's a little bit like granulated sugar. So it's suitable for feeding into other raw material processes like filament production, but also things like roto molding and injection molding. So it can be used straight in those kind of applications as well. But obviously, we then take it on another step. And in Newlyn as well, we have a compounding plant, a small compounding plant where we mix carbon fiber in with that raw material and come out with a pellet with the carbon fiber mixed in, and that then is the OrCA material.
Yeah.
And yeah,
Looking nice. Like a small sprinkles for cakes.
I wouldn't eat them,
Me either.
but yeah.
Yeah, and when you were talking about the resources, when you are getting your nets, can I ask, did you think also about maybe contacting the producers of those nets and maybe recycling the leftovers from their production?
Their production, fishing net production is very centralized. There are maybe 15, 20 big fishing net producers, primary producers in the world, and they are all in Asia, apart from I think one. And their processes have been relatively unchanged since the 1970s when this particular net became popular, and they're extremely efficient. They have very, very little waste in their manufacturing process. We have been in touch with some of those primary producers. They Unfortunately, the volume of nets that are recovered in the world right now is very low, and compared with the amount of primary nylon that they produce, the economics aren't there for them. The nylon that we recover is not in volumes where that they can put it back into their net production facilities. So they would rather carry on regardless and use their primary virgin nylon right now. So we can actually add value to the volumes that we recycle and charge more for our recycled material than they can charge for their virgin material at the volumes that we're doing it. So it's a bit of an economic challenge for them and an economic opportunity for us.
Yeah, but that actually like a happy news for the environment that they are also processing their leftovers and everything. That well, they are able to have these results. That's nice. Nice to hear. At all. And if the second one or the other one question is like, how did you came with the name of OrCA? Yes.
OrCA is it was the code name for the material. When I started Fishy Filaments, I always wanted to do a carbon fiber compounding version of the material if it was good enough. It was always in the R&D plan, always in the roadmap, and it had a code name, and the code name was zero carbon. Um, Net zero carbon was the kind of original code name, so N0C. Now that once we had a life cycle assessment for the Porthcurno material, so once we knew exactly what the carbon impact of that was, the result was actually it's near zero. So the name became near zero carbon, and that's what OrCA stands for. It's the zero is near zero, and then small sub case R is recycled, and then CA is carbon. So it's a development of the original code name for the material as it went through R&D.
Awesome. I was thinking it's because of the color, because I, of course, imagine this
It,
animal
it,
and.
Absolutely, it fitted superbly with all of the imagery around OrCA themselves, and the way that we're developing the material family is very much like a small pod of different sizes and shapes of material that we're going to be releasing in the future. And yeah, the shiny black skin is very evocative there of the actual material. So it matched perfectly in a visual sense as well as being a technical good fit as well.
True. Uh, how long are you working on this project? Because it sounds like a lot of years of research and experimenting and all of it.
So all in all, if you include the kind of run-in before Fishy Filaments was launched, it's probably around 10 years now. The Fishy Filaments as a project was launched in 2016, and then funded as a company in 2017. But there was a number of years before that when I was still working with the metals stage of the R&D, where we were looking at the technology, but it wasn't being applied in a specific way. So it's been quite a long journey, and we kind of come to the end of the first stage, which is developing a material that has genuine industrial application, that is robust and recyclable, that works for sustainable message, but also for mechanical strength and performance. And that was always the aim, to have something that had a genuine industrial and commercial use, not just a nice message and a pretty picture. OrCA was very always wanted to be sold into industry, and that took some development to develop that market. But the bigger and the longer challenge is developing the hardware to roll this out as a solution for the world, and that is ongoing. I mean, we're only in probably the first third of that journey, so that we can install our recycling plants around the world into fishing communities that need them, so that we can provide them their waste management needs, but also recover their end of life nets. And make a genuine difference both in their local economics and their local environments as well. And that impact stage, which is kind of the next 5-10 years, it has the potential to save almost 2 million tons of CO2 a year.
Wow.
Wow. And there's also potential for a billion, more than $1 billion a year of revenue through that. I don't think that will all go through Fishy Filaments. I would
Hopefully.
no. It would be nice if we have a share of that, but it's all about enabling the change, enabling the capture of that material around the world, so that it benefits both the fishermen and downstream industry as well.
Definitely. And why did you choose us, Fillamentum, for producing your precious baby?
Reputation, and you've got great quality products. You have a fantastic distribution network. And you have a really nice and alignment with what we're trying to do as well. So you'll work with products like non-oilen, which is kind of complementary, not competitive, but complementary to what we're doing. Um, it's a really good alignment, and yeah, I was looking for a partner that could meet the challenges that we're meeting as well, and uh, with experience comes the ability to develop and grow, and that's not always evident around the world. A lot of people are a little bit stayed and a little bit narrow in what they're willing to challenge themselves with and challenge other people with. And I think there's a very strong alignment between Fishy Filaments and Fillamentum. Um, uh, a couple of years ago, we both won in the 3D printing industry news, and we kind of met up, and I think we we both share that long-term commitment to a more sustainable industrial ecosystem.
That's true. That's true. Our CEO, Mr. Dolachek, is really interested in everything was sustainable, and also the whole company is thinking this way. So it was very nice, and thank you for your trust and for everything. We're very happy that we can do this with you.
I'm very glad to find a really solid, committed partner. It takes a weight off my shoulders to be able to trust you guys with it. It really does.
Yeah, thank you for that. Is there something? What will you love to tell the new users of OrCA?
Sure. The the initial release of OrCA is a 10% carbon film. That's the first filament that's coming out. One of the things that we're trying to do with the OrCA family of materials is make them so that uh, they are co-recyclable, so that you can print the different materials in the same printed part, and then at the end of the life, you don't need to worry about separating them out. We can recycle them. So, or it is technically possible to recycle them. So, being able to print in different materials in the same body and not worry about decomposing that component at the end of life is actually quite a big benefit. Once we get into, if you like, the second generation of the EU circular economy package, there are some real kind of big benefits in terms of building sale and return business models around circular materials. We're only just starting that journey as a European industrial complex, if you like. But there's definitely a lot of interest in the idea of monomateriality, the idea that you have simple components that are either co-recyclable, recyclable as one, or very simple materials are just one material, because the end of life has a cost as well as the beginning of life. And all the materials we're designing within the OrCA family are designed to be recycled.
Awesome, awesome. Thank you very much. I guess that's all. If you have something, what would you like to say? Uh, Go on. If there is anything, now is the time.
Okay, great. I welcome all of Filamentum and all of Filamentum's customers, and I think it's the start of a great journey on with OrCA. Um, the carbon impact is so low; it's only around 5% versus the virgin equivalents, and we're getting as good price performance out of the material as virgin equivalents. So you can really have some trust in the material that it is sustainable, and it is competitive in a marketplace where performance is valuable. Um, Obviously, it's a relatively new material, so we're not defining what uh, particular sectors we're aiming at. We're making it generally available, and I will love to see all the challenges and all of the solutions that people come up with out there in the wild world of 3D printing, because there are an awful lot of imaginative people out there, and it's the ability to engage with a genuinely engineering grade and extremely sustainable material should provoke some imaginative solutions, and I look forward to seeing them.
We too. Really looking forward, and we already saw few of the usage. Because the Mike from 3D Printing Cornwall, which I already mentioned, is already printing with it, and he has really wonderful case studies. So we are really looking forward to show this to the public.
Yeah, I mean, already two products have launched, I believe, which is fantastic. And yes, I think as I know there are a number of people who are waiting over in the UK for availability, and I get regular inquiries every day for different and diverse uses. So I think it's the challenge is not going to be gaining interest; it's going to be meeting demand, I hope.
Hopefully, we are doing our best. I know it takes some time, but everybody wants to be the product perfect. So quality takes some time, but
Absolutely.
we are releasing OrCA. So when you are watching us, guys, you can already take your look on this one. Thank you very much, Anne, for your time.
Brilliant. Thanks for yours too.